glass. And the way to prevent those kinds of injuries is really to find them in advance. You wouldn't necessarily have to deflect them. It didn't hurt or kill more people than a typical hurricane that makes landfall. And we don't try to deflect hurricanes. But what we do is civil defense. We evacuate people. We tell people to board up their windows. We tell people to take cover. And I think that's what we would do if we discovered another 20-meter object like Chelyabinsk on a collision course.
And there's so much going on in terms of different sizes of asteroids. And you were mentioning a lot the size and the angle in terms of how that might affect the impact. Well, do also things like the speed of the asteroid and maybe what it's made of, do they make a difference in terms of whether an asteroid of a certain size can be catastrophic?
Absolutely. And in fact, there's a big difference between the Tunguska explosion and Meteor Crater. So Meteor Crater is a 49,000-year-old impact crater in Arizona. And the object that formed that crater was probably not much bigger than the Tunguska object, but it was made out of iron nickel. And so it was much more dense. It probably came in at a steeper angle. And so it was able to punch right through the atmosphere. It did lose material, and there was probably a big atmospheric explosion associated with it, but a big chunk of material, of solid metal, hit the ground and exploded when it hit the ground and excavated this large crater. That didn't happen at Tunguska. So the difference is the strength of the material and the density of the material. And there are other factors, like you said, impact velocity and angle of impact. We really don't have any information about that except for what can be inferred from the structure of the crater and from the debris field around it, what direction it came from, and or how steeply it came in, or what the speed was. We know it came in at greater than escape velocity. All impacts do that. But it could have been much more than escape velocity. We just don't know.
And so, yeah, in this first segment here, we've talked a little bit about sort of Asteroid 101. We've learned about, what makes an impact and what different sizes of asteroids can do to affect that. And as we're going into the second segment, we'll be talking a little bit more about what, B2Bomber can mean in terms of getting a little close. And so thanks for sticking with us. We'll be right back just after this quick commercial break. And we're back. I'm your host, Eric Edelman. I'm here with Dr. Mark Boslough, and today we're talking about asteroids, in particular, one asteroid that has been known as the lost asteroid, or the B2Bomber. And so earlier in the program, we talked about, different sizes of asteroids and how frequently maybe they have a chance of impacting Earth, and how many of them we know are out there, how many of them we're tracking. And so one question that I'd like to pose to you, Dr. Boslough, is what sort of in a perfect world, in your mind, if we had all of our ducks in a row, what would we be doing to look out for these asteroids? What would be like the perfect asteroid protection scheme?
Well, I think the first step of protection is discovery. If we discovered something big, big enough to threaten the entire kind of civil defense, take cover. So really the first step is discovery, and that's really been NASA's approach, is the Space Guard survey and the follow-on surveys that have been doing a very good job building up the catalog of observed objects and calculating their orbits and determining the probability of impact. But really, the best thing to do would be to accelerate the rate of discovery. And the best way to accomplish that really would be to have a space-based infrared telescope, because a space-based telescope can, can look in more directions than an Earth-based telescope. We can't look for objects in the daytime sky, and a space telescope, a space telescope can't look close to the sun, but it can see a much larger area of space, and infrared is much more sensitive to asteroids than visible light, and so we can see smaller objects. And so the discovery rate would increase markedly if we had such a space-based telescope. And there are proposals to build and launch such telescopes. So that would really be the next step, because you really can't defend yourself from something that you don't see coming. And like you have pointed out, this particular object, it's very small, and we already know that it's not on a collision course, at least not for the next 100 years. But an object like that, clearly, if we didn't have that pre-covery, that 10 days prior to our loss, we would not know that. I mean, we know now that it's not going to hit us, but if we didn't have that pre-covery point, we wouldn't be able to tell you with certainty that it wasn't going to hit the Earth. And having more assets, more telescopes, especially in space, would keep that from happening.
Do you
Because
feel like we're
we
at
will
the point?
discover things, we will discover things that we won't know for sure are not on collision courses. This is bound to happen in the future.
Mhm. Yeah, do you feel like we're at the point where we still could get surprised by a significantly sized asteroid?
Absolutely. Chelyabinsk came out of the sun. It came from the daytime side, and there was no way we could have seen that coming. There, with the telescopes, the Earthbound telescopes that we have, and at any time an object could come from that direction. It's very, very unlikely that a big object would, bigger than a kilometer would come from that direction, because we almost certainly would have seen that by now. But a smaller one, certainly, and that's really why we need a space-based infrared telescope that can look in that direction.
Right. Yeah, absolutely. Well, thank you so much, Dr. Boslough, for speaking with us today. It's been really enlightening to hear about really what is going on with all these objects zipping around us throughout space. And I really hope that you can come on one of our shows again. It's always so much fun to talk with you.
Okay, good. I'm glad to help. Thank you.
Thank you. And so, yes, we've been talking a lot today about asteroids, and particularly about that one particular asteroid that has been on everybody's minds, the B2 Bomber, asteroid 2013 TX68. It's one that has passed by Earth successfully, but as we've been talking about today, there's going to be asteroids similar to this where we have a little bit of uncertainty in that orbit. And the question is, are we at the point where we can figure out what all those orbits are for the ones that are maybe dangerous for Earth? And, maybe we do need a satellite up there floating about in space, looking at more things than we are currently. It's something to investigate, something to think about. And I hope that you've had a fun time watching this show. Now, of course, there's a lot more shows coming up on Slooh. One will be coming up just this next Tuesday on Down to Earth, a little show that I host here on Slooh, where we're going to be talking about time travel. So I ask that any people that have potentially watched this show in the future and time traveled back, please don't spoil it for everybody else. We're very much looking forward to it. But for now, this has been Eric Edelman, and you've been watching Asteroids on Slooh. Thanks again.